All right. Well, hopefully everybody did an awesome job with 6.1 and was able to apply the normal CDF using our central limit theorem. So now what I want to look at is making sure that we can use the central limit theorem correctly. And so what this is going to be is we're going to have some problems where we're looking for the total number of people. Sometimes we're going to be looking for a single person. And so we want to make sure if we're dealing with a single person, that means we're doing like we did in chapter 5, not modifying the standard deviation. If we're looking for the whole group of people, then we are going to apply the central limit theorem to that one. All right, so if we look at example 1, we've got assume that women's weights are normally distributed with a mean given by 143 pounds and a standard deviation given by sigma equals 29. If one woman is randomly selected, find the probability that her weight is above 140 pounds. So with this one, since we're looking at one woman, we want to make sure we're just doing the normal CDF from chapter 5. So when we set this up, we're just going to have the normal CDF. And so we're trying to find above 140 pounds. So in this case, that's going to be our lower bound, some ridiculously big number, our mean, which is 143, and then our standard deviation, not modified. So just plain Jane, just like that in this case. And so I'll leave that for you guys to type in the calculator. But again, since it's 1, we're not using the central limit theorem. For this one, we're just using chapter 5. All right, so for B, so notice in this case, if 100 women are randomly selected, find the probability that they have a mean weight greater than 140 pounds. So in this case, we are going to use the central limit theorem because we're trying to find the average weight of 100 women and see what the probability of that being greater than 140 is. So as far as setup goes, it's going to look exactly the same until the standard deviation, in which case we're going to do 29 divided by the square root of 100. And so again, I'll leave that for you to type in the calculator, and hopefully you'll see what a vast difference those two probabilities are going to be between finding an individual person that has a weight of 140 or more compared to 100 women averaged having a weight of 140 or more. All right, so for C, we've got 4 women are randomly selected. Find the probability they have a mean weight between 135 and 145 or 140 pounds. So since this is 4, are we allowed to use the central limit theorem? Well, normally, remember, normal central limit theorem says we have to use it if we've got more than 30, but there was one other stipulation. If the data is already normally distributed, then we can use the central limit theorem for any number of people that we're surveying at all. So in this case, since we know it's normally distributed from the beginning, so we can use central limit theorem for this problem even though our n is less than 30. So again, let's go ahead and set this up. So since we're doing between 135 and 140, that's going to be our lower and upper bound. So 135 for the lower, 140 for the upper. Still our same mean, but now we're going to modify our standard deviation based on the number of people that we're surveying. And so again, go ahead and type that in the calculator. Make sure you get that down. And so again, for part D, why can we use the central limit theorem even though our sample size did not exceed 30? Because our original set of data was normally distributed. So if we've got a normally distributed curve, then it doesn't matter the sample size or the size that we're interested in studying. So unless it's one you would still, I mean, even then you could use central limit theorem, but when you're dividing by 1, it's just going to be the same thing as the original. But you could do 2 or 3 or 4 or anything, any number like that. So, all right. So for these, what you want to do is just make sure, are we looking at one person or are we looking at a bunch of people? If we're looking at one person, then we're going to use the central limit or the normal CDF from chapter 5. If we're looking at multiple people, then we're going to be using the central limit theorem, normal CDF. So again, I got a bunch of practice problems for you guys to work on. So make sure we work on practice 1 through 5. And then when you're done, I'll see you at the next video. So good luck.